one of those moments where you decided you weren't going to film something, and then something interesting happened and you regretted not filming it? Well, I was working on the Akai reel-to-reel machines. The nicest one had a servo failure. So I did put a power cord onto the junk parts unit to see how it would work, and its servo sort of worked, so I figured I'll take some measurements on this as a reference. Took some measurements, it went fine. What I measured was this head here that measures the tone wheel on the servo motor. When I hooked this machine's head up to my oscilloscope and turned the power on this unit, the logic control board exploded. This trace right there burnt open. This cap, I believe it was a 10 microfarad 25 volt, blew up. We got a nice resistor carnage right there in the middle of the screen. Another resistor carnage on a rework under the board. Just general chaos and destruction. I wish I had filmed that. That would have made interesting video. So I'm going to try to rework this board a little bit. This is, I believe, the logic control board for the motors of the transport. Basically, it controls the different modes it's in and works these and the on-off for the servo. The servo's got its own board, but I believe it's commanded by this board to start and stop. No, it doesn't. It runs continuously while the machine's on. This board controls everything but the servo, basically. After that whole explosion occurred, it was stuck in the forward mode, and it won't come out of it if you hit stop. It won't come out of it with either of these modes, but it will go into fast forward briefly. And despite being stuck in the forward mode, the capstan no longer pulls in, so some pretty big crap went down. I'm hoping I can get it back to where it was and then start troubleshooting the servo. I know why it exploded. This power transformer right here, I'm pretty sure has a primary to secondary short, because if I measure the voltage between the chassis ground on this machine and the ground on my oscilloscope, which is grounded to building ground, there's a 130, something like that, volt, or a 64 volt AC difference between the two, depending on which way I plug in the non-polarized plug on this unit. This one, chassis ground, there's no differential between this and the scope ground, no matter which way it's plugged in, so clearly this one has a good power transformer. This one has it works, but not if you try to ground the chassis to anything that's grounded power transformer. So I'm probably, if I get this machine working, I'm going to have to steal the power transformer from the other unit. Oh, what fun. This thing's even more foobar than I expected. I didn't notice this trace was burnt up, and I should have. There's also, can I spot it? That guy right there that's burnt open. In addition to the one on this side, right in there, there's I hope I can make this work again. If I can't, I'm going to have to try a board swap. I don't know if the other board works, because I remember the logic control for the motors in operation on this other parts machine wasn't working quite right either. I hate it when I wreck my only good board. Reel-to-reel update. So, after spending a lot of time working on the board that I blew up and replacing, virtually every transistor on this board except for around 3, and putting it into this machine, I discovered that the board that was in my parts deck before this was actually a better functioning board than this machine, so I put that in. I also transplanted the capstan servo speed regulation board, and then I proceeded to dewire the power transformer and discovered that the power transformer was not shorted. And then I tried to dewire the servo motor, because I thought that might be shorted, since that's really the only other thing that would be live at all times that would be connected to power that could short the chassis, and that was fine. And eventually I found wiggling some of the wiring and wiggling this board could change the short to chassis. I never found the exact source of it, but I was able to wiggle it out of existence to a point where it's not coming back no matter what I do to the thing, so I guess I fixed it. I really don't know. But it hasn't come back, so I'm happy about that. With the new servo board in, it now runs at the correct speeds when the speed selector is punched up, and it seems to actually work okay. The only complaints I have about it right now are when it's powered on and running, if you put it into rewind mode, the rewind doesn't light up, but all the other lights work properly. So I guess this is a burned out bulb. Honestly, I don't give enough of a darn to go in and change the bulb. It's a pain in the butt to get in there, and I don't give enough of a dang. It won't go into record mode no matter what I do, which is frustrating. It plays back fine in quadraphonic mode and in stereo mode on side 1. If in stereo mode I kick it into auto reverse or punch up the reverse playback direction, the audio is almost completely muted, but a little bit leaks through. There's supposedly a relay that's supposed to switch the playback heads from what would normally be the back channels into the front channels when playing in reverse mode in stereo. I'm guessing that relay is not operating. The schematic doesn't make it very clear which relay it actually is or what board it's located on. So I haven't the foggiest which relay it is or how to check it since I don't know which part it is in the unit. Yeah, aside from not being able to record and in stereo reverse playback direction at muting audio, it seems to be working perfectly. So I'm at the point of clean it, throw it back into the cabinet, and sell it. I actually completely harvested the capstan servo motor out of this machine while I was in the middle of trying to track down the short, because I figured, well, it's got to be this piece. So now this is separated from that machine, and I'm actually thinking about keeping this out of this machine and maybe a few other parts out of this machine. There's a potential use for this servo. This servo can spin like 1450 RPM, and it's got the head for speed regulation pickup. Basically, the servo takes around 110 volts AC on these three wires to drive it without regulation, and then these two orange wires here, these orange wires are somewhere between 0 and 24 volts DC as a braking winding to slow down the motor from its unregulated speed to regulate its speed. I actually have a little plan for this motor if it has enough oomph. Back in the 1950s, very soon after the 1953 NTSC electronic television standard, someone figured out that you could take the old color wheel mechanism on from the defeated CBS standard, spin the wheel at a different speed so that it would essentially match up with the NTSC frame rate, demodulate NTSC normally, feed it into a monochrome picture tube, feeding one color at a time into the monochrome tube, and use a color wheel to get a color image. The color tell, and there was another converter from that time period, used that principle and worked quite nicely. Those took a 1200 RPM motor, geared it down to 600 RPM, and synchronized that with the deflection circuits. This motor can go above 1200 RPM, so if I use the right pulleys to down gear it to 600, at unregulated speed it would work fine, or if I direct drove a color wheel off of this, I could probably regulate the speed of this motor down to 600 RPM and use this motor direct drive a color wheel. It's not a very big motor. I don't know how much torque this thing can produce or the amount of wheel inertia it can support, but I have an idea to make this drive a small color wheel for certain applications, and that's probably what I'm going to keep it for and do with it when I have time. What else? I think I'm going to take a whole bunch of parts off of this chassis and then probably just scrap out the metal framework on this parts deck, because I bet no one's going to buy this thing from me. Theoretically, I could make a little personal color wheel viewer out of this motor, or maybe a color wheel for a Norelco protogram, or a small monochrome set. It could be a fun project. This is my Akai 1800SS quadraphonic 8-track with 8-track cartridge playback and built-in amplifiers with speakers. Only stereo for the built-in amplifier, but yeah. So I need to figure out why the I believe rear left channel is dead on both 8-track and reel-to-reel operation. So I got it here. I think one of these wires was one of the ones I had to resolder and splice, because mice ate part of this, but I might be wrong. Yeah, I think I can see my own workmanship. Time to figure out what's going on with this. Figured out the problem with this. All 4 needles are going now. The problem was that the cart reel-to-reel and transfer switch trio was dirty. I had to spray some control cleaner into it and work these a bunch of times, and I got my my sound back on all 4 channels. This is the rear 2 channels. And this is the front 2. Queen Latifah? This is someone's homemade disco tape. It's not a quad tape, but stereo 8-track tapes will play as quad in this machine. You'll just get 2 different songs in stereo, one in the front and one in the back. Let's go over to reel-to-reel. That's the front channels. Come on. Go back to cartridge. Let's see if I just... Oh, gee, thanks, auto stop. Okay. Well, I still haven't completely fixed it, but I'm working on it. Okay, I think I got it this time. That turns off the rear channel, so that's why audio drops out there. I'll just leave this on for copyright purposes and to amuse the chipmunks. I think I figured out what the problem was. See this little board in here? You can push it back and delatch it from that little top catch and pull it out because it's a card. I'm going to relatch it because I don't want to pull the whole thing out. But it's basically the head amp card. And I believe these two transistors here and here for the right rear channel, which were, you can't even see, can you? Prodding with a metal tool inside a live device. Now, this is a great idea. I believe this transistor and this transistor here, one of them was the Am I filming it? Yeah, I am. I believe this transistor here and this transistor here were the problem with this unit. They're for the right rear channel. I believe this is the left rear channel, the right front, and the left front. The right rear channel was intermittently losing almost all of its gain. I did a bunch of things probing around with my, I've got a function generator here. I took its cable, ground it to the chassis, took the hot lead of it, I put a series capacitor so I could do signal probing like that. And I could trace things around. I touched up some solder joints on the switches and some other things. I thought I had it right, but eventually, after thinking I fixed it a couple times, it ended up dying on me where I could take the output, which is here, and I couldn't get much output. I could probe the input, and I could, I wasn't getting much input either. I pulled the entire card out, and while probing it, and when I pulled the card out of the socket, all of a sudden the gain on this output wire shot up. So the amp board was actually loading down its own output with, I think, the output transistor, which would be the topmost one, probably shorting out or something. At least that's my working hypothesis. I don't know for sure. Hey, Alvin, shut up! So, what I basically did is I took my junk parts 280 deck, took one of the keepers off of its board, and of course I grabbed a different module. That's just like me. So I took my parts 280 deck, took the keeper off of this pair of modules. These are the two transistors that came out of my 1800, these ones with yellow tops that have a little bit of red Sharpie on them. I paint markered them yellow and then I did them up red. I've got a red paint marker, but it's not on this floor and I didn't want to hunt for it. But I figure those markings are enough to tell me that those transistors are don't borrow. They're the same exact part number transistor, C458, I believe, as the ones in the 1800s. So this thing actually was a good parts machine for waking this one up. And why the hell am I injecting color bar generator into a cable that goes to the VCR and listening to the audio on the TV? Well, my wonderful Akai bench system here is also a piece of junk. This one, right now if I turn it on, I could probably punch up tuner or phono and get it to work perfectly. If I try to put it into aux mode, it might work for a while, but sometimes the aux input, the aux line input actually dies, which is annoying. Don't ask about cassette. Cassette's foobar, and this amp is ridiculously hard to service. I once almost threw it out over it blowing its speaker fuses because you literally have to take apart about half of this machine's amplifier section to get to the board that has the speaker fuses to change them. It is bad. And Akai apparently was doing this for a long time because just look at the serviceability of this thing. I mean, yes, you can access these two boards, and yes, you can pop out that module that I worked on there, but the board behind it, I have no clue how you would service without completely tearing the machine apart. And that board was the one I initially wanted to do signal injection testing on and checking on, because it was the one I initially thought was the culprit. So, yeah. And then there are little boards that are screwed in here and that are screwed in under here and over there, and some more that are buried underneath the 8-track mech. I have no clue how Akai intended you to get at some of the boards that are in this machine, short of just tearing the entire machine apart, which is just stupid. Make your printed circuit boards accessible so that if somebody needs to fix something, they can fix something. There's no point in doing all of these beautiful little plug-in module cards to make things all disconnectable if you can't get at the stuff that you want to disconnect and service. Rant over. Let's go back to Alvin and the Chipmunks. Oh, some big band. Those are on the front channel. I think. They should be. Well, oh! Well, it helps if you plug into the output and not into the recording input. There, now Alvin and the Chipmunks are no longer having a stroke. Okay, so on the Akai, I determined that, unlike what the conclusion I filmed says, the problem is not on the plug-in module board that's inside the machine, but rather that big impossible-to-get-at board that is just inside the face panel here in an area that might be impossible to get at, but might not be impossible to get at. Not sure how to get at it. One possibility is that I pull out these screws on either side of this module, and maybe I can flop the whole face out to reach it. I have no idea. I thought it was impossible before, just now looking at those screws, but we'll see. At any rate, right now I'm doing a completely different ritual. This is my blonde Motorola VT71. The chassis is electrically restored. The cabinet is pretty poor, particularly the bottom, which has about the structural integrity of a potato chip. Most of the layers of the plywood have evacuated and gotten lost. This is my 8-inch Motorola, which uses the same chassis, and I have them back to back because I'm using the restored chassis in this set to drive the, I believe it's an 8BP4 CRT in this set, or 8JP4. It's the 8-inch version of the 7JP4, which is a fairly rare tube. Proving that that tube is good using the restored chassis is sufficient to tell me this set is worth keeping. Also, I'm about to start migrating the good parts from this cabinet into the much better blonde Motorola VT71 cabinet I got right there. I think you can see all of the encrusted gack from the mask having melted in that set. This is going to be a fun process. I'll try to give you some updates. Well, if I said anything about this Akai being unserviceable earlier in the video, I apologize to anyone who knew how to work on this unit who was offended by that comment. So it turns out that this incredibly hard to get at board isn't actually that bad to get at. Basically, you have to take the entire front bezel off, which is 4 knobs and I believe 5 knobs and 4 screws. Then you have to take out about 6 screws on the face panel. There's a couple here, there's a couple here, and there's like 1, 2, 3, maybe Maybe it's 8 screws on the front panel. At any rate, once you do that, you can hinge the whole front panel down. This board is actually normally rotated around and mounted onto the inside of the face piece, but I've demounted it to troubleshoot. Some signal injection probing has shown me that the op amp, which I believe is this one right here, is working okay. What's happening is that the signal line is shorting right here. And I'm pretty sure it's shorting inside this tunable inductor. If we look at the schematic, it is this dotted box right here. The 2.2K resistor is that guy. There's each channel is identical, so it's this box here with this 2.2K resistor. I disconnected the 470 picofarad cap C1 to see if that was shorting audio out, and that is not the case. So something in this transformer, I think here or here, I found the strongest attenuation seems to be in the coil assembly itself. I can inject around the resistor when the audio drops out and there's no real problem. It dropped out again on me. So something went wrong in that coil. I'm not exactly sure what that tuned inductor is. My best guess is it is a low-pass filter designed to prevent RF from the recording biases leaking over into the op-amp circuitry. So my short is inside this can right here, so I gotta switch this thing off and pull the can out and see if I can figure out what goes on inside that can. As much as this design is serviceable, it is not super obvious how to get to that stuff unless you've been in this thing before. I've seen a lot of reel-to-reel machines where if you can remove a bezel, there's not much underneath it, so I honestly wouldn't have expected this unusual means of access, but it does actually work. Why they needed to have that giant metal panel at the very back that the input-output RCA jack board is mounted to, why they needed to make that a giant metal panel that completely prevents access is beyond me. But, yeah, now I've gotten into it. Now I've got to get into it some more and take that little transformer off and hope I don't destroy it. I guess if I do, I'll just have to figure out a 3 dB or a 6 dB low-pass filter that cuts off at roughly 20 kilohertz. Okay, wish me luck. Okay, so I've determined, or at least I think I've determined, it's not this transformer. This is one hell of a phantom problem, but I think I'm finally on its tail now. I've got one of my multimeter leads clipped to the ground. Now, this purple wire is the output that feeds the op-amp chip through the level potentiometer. It feeds, I believe, this op-amp chip here. And if I put my meter on the lead that feeds it, the VU meter will start flicking. This orange wire over here feeds the other op-amp channel. Well, maybe that isn't the problem. I was doing that test on the other op-amp channel if the level turned down, so it didn't do that. This thing is confusing the living hell out of me. Maybe it is the transformer. Well, there's always the option of desoldering the damn transformer again and just running without it. So, I think I've found the culprit for the nth time. I was wrong about this transformer here. I actually bypassed it completely, taking the two hot leads. One goes into this transformer and the other one comes out of it. Technically the one that goes into it through a resistor, but at any rate, I took the two hot leads, jumpered them together. After doing that, the channel still dropped out anyway, so that eliminated that as a possibility. Then I decided, well, the only thing after that, other than the potentiometer, which I highly doubt the potentiometer would have failed and it tests fine electrically. The next two things that were possible as culprits is the cap and the IC. This cap here, which I've temporarily put a film cap in place of, and the IC, I tested to see which one it was by, basically, I soldered two of the leads of the two capacitors, the original and the replacement, together to one terminal, and then the other terminal I jumpered, and I initially had it hooked to the capacitor. I waited till the channel started to drop out, then I switched over to this capacitor, and of course the intermittent channel dropout stopped when I switched to the new capacitor, but I waited it out while it was hooked to the new capacitor, and with the new capacitor in and the old one disconnected, the channel dropout happened again. So after a little bit of prodding around and seeing if I could do further diagnosis, I replaced the integrated circuit chip for the heck of it. I've got replacements from this parts machine over here, so this is the one that came out of the machine, and the replacement from the parts machine is in there. They're the exact same part number, and they're out of very similar vintage Akai machines, so seems to be a viable replacement, and the replacement doesn't seem to be acting up. Now, just because it doesn't seem to be doesn't mean it isn't going to, and that the problem isn't somewhere else. This machine has faked me out into believing I've fixed it so many times that what I'm going to do, after I've done just a pinch more work here, is I am going to button this whole machine back up, and then I'm going to leave it on the repair bench one more day, and I'm going to try it out tomorrow and see if it runs for one full album worth of time without giving me a channel dropout. If it does that, I'll declare victory. Honestly, with this channel dropout issue, I've actually found that if I leave the machine dormant overnight, the issue usually is there as soon as I start it up, so I probably wouldn't even need to run it that long to confirm the issue, but I'm going to. One of the things I'm heavily leaning towards doing is replacing each one of these 0.47 canlytics, these 0.47 microfarad, with film caps. This one here is a 630 volt film cap, which is gross overkill. It'll last for way longer than the unit will, theoretically. The original was only rated to handle 50 volts, and electrolytics degrade much faster than film caps. I may also replace the 10 microfarad electrolytics on the output of the transistor that is driven by the IC, just as a precaution to prevent damaging the output stage. The reason I'm planning on replacing this input capacitor is it has 23 ohms of ESR and about a 5% voltage loss according to my Chinesium component tester. Yeah, I think that is pretty excessive for a capacitor, especially one that's that old. Really, it might be advisable to just recap this entire board and this entire machine, but I don't have all the lytics I need to do that on hand as new parts. And frankly, I don't want to spend the money, and it seems to work pretty good with the caps that are in it right now. So I'm just going to change a few in this stage to help protect the integrated circuit chip so that they continue to last, because I think I only have maybe 3 to 4 more of these chips. I have just enough to, I know I have at least enough to replace the ones that are here, all of them, but I don't know if I have any beyond that, and I'd like to make sure these chips don't just die off on me, or that other channels don't start dropping out the same way. My hope is that this repair will be sufficient to keep this entire unit working reasonably well for the next 10-15 years. I'd like to not need to mess around with it for a significant period of time. I've gotten my fill of messing with this thing. I think that concludes the video. I'm gonna put this back together and get it back in my main stereo system upstairs. If you enjoyed this dumpster fire of a video of me scabbing any random transistor I could find in the bag into this control board that I blew up, and all of the other stupid things I've done, please leave a like, and thank you for watching. Consider subscribing for more madness. Okay, and it's fixed and right back where it belongs. The Akai 1800 If you like this video, please give it a thumbs up, and consider subscribing for more content like this. Thanks for watching.